Hello, my name is Karpasamy. I'm going to be doing my 8th lab experiment. The experiment is on process creations. So we're going to use some system calls to create processes. The main system call that's used here is fork system call. So the first program is write a C++ program to create the following process hierarchy. So the parent is A and then the child is B. So the process A gets a second. So with the process A, we'll get the input, and then the process B will calculate and display hours, minutes, and seconds. And then we're gonna print the process ID and the parent's process ID. So the program is over here. So this is the program. So first we're including all the header file that is necessary, and then we're initially declaring three different variables: seconds, minutes, and hours. And then we're printing parent process, and then we're giving the parent process. So for getting a process ID, we have to use get PID. So this will get the process ID, and then we'll display it, and then we'll ask the user to enter the seconds, and we're storing it in seconds variable, and then we're creating a process by using the fork, and then we're storing its process ID in PID. And then if PID is equal to 0, that is, if PID is 0, it means that the process is created successfully. So if the process created successfully, we are doing these operations. So we're first printing child process, and then we're giving its process ID, and then we're displaying parent ID, and then we're using get PPID, which means get parent process ID, and we're displaying it, and then we're calculating hours, minutes, seconds using the value that the user just sent. So for hours, 3600 seconds makes 1 hour, so we're using that. And then we're using seconds modulus 3600 divided by 6 years minutes, and then minutes modulus 60 divided by 60 is seconds. And then we're printing all three values that we just calculated, and then finally we are putting the processes. So now I'll show you how the thing takes place. So first we're entering the seconds. So let's say I'm giving 3660. So what happens is the child process created here, and then this is the ID, and this is the parent process when the parent process was created, and then we're displaying hour, minute, and then the second. So 3660 is 1 hour and 1 minute. So the next program is 8B, and the question is over here. So here we're having the parent process A, and then two of its child process B and C. So what the parent process does is it takes a string as input, and then process B reverses the string and displays it, and process C checks if the string is palindrome, and we're going to print all the process IDs. So here is the program. So we're declaring two strings, string 1 and string 2, and then first we're having the parent process here, and we're getting it by using get PID, and then we're asking the user to enter the string, and then we're scanning the string and storing it in str, and then we're finding the length of the string using strlen function, and we're storing it in L, and then we're displaying strings length, and then we are creating a process using the fork system call. And if the process created, we're displaying child process, and then its process ID using get PID, and its parent process, that is the process of A, and then what process B does this, it reverses it. So what we're doing here is we just displaying the string in the reverse order using this for loop. And then what happens is finally the process C is created, and when process C is created, similarly we're displaying its process ID, and then the parent's process ID, which is the process ID of A. And then what happens here is we are checking if the string is palindrome, and for checking the string is palindrome, we're just going to reverse the string, and then we're going to compare it with the string the user entered. So if both are equal, it means that the string is palindrome, and if it's not equal, it's not palindrome. So this is it. Let me show you the output now. So first, the first process is created, that is process A, and then we are giving Malayalam, which is a palindrome. And so as you can see, first the string length is displayed, and then the reverse of the Malayalam is Malayalam, and then the third process, that is process C, it checks if it's palindrome, and because it's palindrome, it has displayed it. So this is 8B, so 8CS over here, and let me show you the question now. So what happens in the final question is, there's a parent process and then two child process for it, and then the child process B has its own child, and child process C has its own child E and F. So the process A reads an integer, process B finds a factorial, process C checks if it's an Armstrong or not, process D checks if prints its Fibonacci series, process E checks the number for prime, and process F reverses the number, and we're going to print process ID and the parent of the process ID. Similarly, just like the previous two. So the question is over here, I mean the program is over here. So initially, we're giving the header, and then we're asking for the. We're going to display the parents. I mean, the process ID, that is process A's process ID, and then we're asking the user to enter an integer because that's what process A does, and then we're storing it in N. Then we're creating a process. So this is process B, and then we're displaying its process ID in over here, and then the process ID of A, that is the process of process A's process ID, and then what B does is it finds a factorial. So is it finds factorial. So for finding the factorial, we're using this for function, and then we're displaying the value using this print statement. And then what happens is B's child is process D, so process D is getting created over here because we're using for function, and then we're printing it the parent's process ID, that is B's process ID, and then child ID is D's process ID, D process ID, and then what process D does is it prints Fibonacci series. For you printing the Fibonacci series, we're using this file, and then so we're putting the process to sleep after it's over, and then what we're doing here is we're creating process C, which is the child of process A, and then we're going to print the ID of process A and then the process C, and then what process C does is it checks for Armstrong, and for checking for Armstrong, it's over here. So what happens is, for example, I'm giving 153. It cube roots 1, 5, and 3. So for getting the digits, we're using this r is equal to on modulus 10, and then for for 153, once I remove 3, we have to get 15. So for that, we're using this one, on is equal to on divided by 10, and then we're individually getting all three digits, and then we're multiplying each of them with each of them, and then three times. And we're finally adding all the values, and then if the value is equal to the original number, it is an Armstrong, and if it's not if it's not equal, it's not an Armstrong. And then process E is created over here, and the parent's process ID is printed over here, and then the child process ID is printed over here. So what the process E does is it checks if it's a prime number or not. So a prime number, what the condition is so take for example the number is 10. So from 1 to 10, no other number should divide the number 10 other than 1 and the number itself, that is 10. So if any other number divides 10, so it's over here. So if it divides the number 10, and if the modulus value is 0, it means that it's not a prime number. So we're incrementing it. So if the value is greater than 2, because the number 1 and 10 includes in the 2. And so if that's the case, it is a prime number. If that's not the case, it's not a prime number. And then the final process is left. So we are displaying the parent process ID and then the child process ID. But then we're initializing A as n. That is the integer that we just got, and then what this does is it displays the reverse of the number. So the reverse of the number is similar to the Armstrong number, but just what you have to do is we have to concat the numbers together. So first we're getting the number in the in the unit digits place using this modulus, and then we are multiplying it by 10, and then we're adding it with the rest of the number, and then we're over here we're shortening it. Like for example, 10, first 0 will be extracted, and then uh, 10 will remain, and by this we'll remove the 0 and 1 will remain, and when it goes back to MO, the 1 will get extracted, and then here it will be added with the 0. So 0 into 10 is 0, and plus 1 will be 1. So the reverse of 10 will be 1. So the value will be printed over here, and then these pods are put to sleep. So let's see the output now. So the process A, who is the parent of all the processes, is the ID is displayed over here. So we'll enter 10 itself. So as you can see, first process B is created. The parent process ID, that is A's ID, is displayed, and the child, then the factorial is displayed, and then process D is created. The parent is process B, and then so as you can see, the ID is printed correctly, and then D's ID is displayed, and then Fibonacci series number, like 10 numbers are displayed over here, and then process C is created, and then it checks if it's an Armstrong number. Because it's not an Armstrong number, it displays not an Armstrong number, and then process E is created, and as you can see, the parent ID and the child ID is displayed. And if it checks if 10 is a prime number, and 10 is not a prime number because it's divisible by 2 and 5, and then finally process F is created, and as you can see, the parent ID and then the child ID is displayed, and the reverse of the number 10 is printed, which is 1. So that's it. It's all over. Thank you.